Hello students, in today's lecture we are going to learn how to find inverse Laplace transform using partial fractions. In earlier videos you can refer how to do partial fraction. We have already uploaded the videos on our channel. So before learning this concept, we recommend you that go through that video first, how to find or how to do partial fractions. So let's start with the topic inverse Laplace transform using partial fraction. Now in this video, there are different cases. The first case that we are learning is inverse Laplace transform using partial fraction. For this partial fraction method, it is required that the degree of numerator should be less than degree of denominator, as well as the denominator are factorized into real roots. So what we will do, we will first check the degree of denominator as well as degree of numerator. If the degree of numerator is less than the degree of denominator and the denominator is factorized into two different factors or three different factors we can say, and these factors are real, then we will use this method. So this is the basic introduction about the method. Now let's start with the examples based on it. Let's learn example based on inverse Laplace transform using partial fraction. Now in this example, the question is find inverse Laplace transform for the following examples. The first example is 3s plus 7 upon s square minus s minus 2. Now if you observe, the degree of numerator is 1, degree of denominator is 2. So clearly degree of numerator is less than the degree of denominator. As well as if we factor this, now using calculator you can find the factors of these terms, and the factorization for this term will be s minus 2 into s plus 1. So we can express this term as 3s plus 7 upon s square minus s minus 2 is equal to 3s plus 7 upon s minus 2 into s plus 1. Now, if you observe the denominator, it is factorized into two linear factors. So, with the help of partial fraction, this is the case 1 of partial fraction, and it can be written as a upon s minus 2 plus b upon s plus 1. So, if you just cross multiply and cancel out the denominator, we get a into s plus 1 plus b into s minus 2 is equal to 3s plus 7. Now, we will choose the value of s so that one of the brackets will be 0 at a time. So, if we put s equal to 2, we get a into 3 plus b into 0 equal to 3 into 6, 3 into 2, 6, 6 plus 7, 13. Therefore, a is equal to 13 by 3. Similarly, if we put s equal to minus 1, the second bracket will be, the first term of a into will get 0. So we get a into 0 plus b into minus 3 is equal to 3 into minus 1 plus 7, that gives you 4. Therefore, b is equal to minus 4 by 3. So in this we have done partial fraction. Still, if you have doubt, a detailed video of partial fraction is already uploaded. We recommend go through that video and then again come to this step. So the value of a is 13 by 3, b is minus 4 by 3. Therefore, 3s plus 7 upon s square minus s minus 2 is equal to 13 upon 3 divided by s minus 2 plus minus 4 by 3 divided by s plus 1. Now, we will take L inverse on both sides. Therefore, L inverse of 3s plus 7 upon s square minus s minus 2 is equal to L inverse of 13 by 3 upon s minus 2 plus minus 4 by 3 upon s plus 1. Now, using the linearity property, we will get 13 by 3 L inverse of 1 upon s minus 2 minus 4 by 3 L inverse of 1 upon s plus 1. Now, with the help of inverse Laplace transform formula, the formula is L inverse of 1 upon s minus a is e raised to at, and L inverse of 1 upon s plus a is e raised to minus at. Now, with the help of these two formulae, we can easily get that L inverse of 1 upon s minus 2 will be e raised to 2t, and the L inverse of 1 upon s plus 1 will be e raised to minus t. Therefore, the final answer is L inverse of 3s plus 7 upon s square minus s minus 2 is equal to 13 by 3 as it is. Using the formula, L inverse of 1 upon s minus 2 will be e raised to 2t minus 4 by 3 as it is. L inverse of s plus 1 will be e raised to minus t. As the denominator is same, we can subtract the numerator. So 13 e raised to 2t minus 4 e raised to minus t divided by 3. This is the inverse Laplace transform of 3s plus 7 upon s square minus s minus 2. So basically what we have done, we have used the partial fraction method to solve the example. Now let us study one more example so that the concept get cleared more clearly. Now let's study one more example so that the concept of inverse Laplace transform using partial fraction for the case 1 get cleared. Now, in this example, we have to find the second example is s plus 3 upon s square minus 4s minus 32. So what is our criteria? First, we will check the degree of numerator and denominator. So degree of numerator is 1, degree of denominator is 2. Therefore, clearly, degree of numerator less than degree of denominator. As well as, if you factorize this using calculator or manually also, the factors x square minus 4s minus 32 will be s minus 8 into s plus 4. So, the factors are real and degree of numerator less than degree of denominator. Therefore, we can easily find the inverse using partial fraction. So let's start with the solution. So s plus 3 upon s square minus 4s minus 32. First of all, we'll factorize the denominator. S plus 3 upon s minus 8 into s plus 4. Now, clearly the factors are linear and different. This is the case 1 of partial fraction. So it can be written as a upon s minus 8 plus b upon s plus 4. Now if we do the cross multiplication and cancel out the denominator, we get a into s plus 4 plus b into s minus 8 is equal to s plus 3. Now we have to substitute one value of s so that out of these two brackets, one will be 0. So if we observe, if we put s equal to 8, we get a into 12 plus b into 0 equal to 8 plus 3, 11. Therefore, a is equal to 11 upon 12. S equal to minus 4. Therefore, a into 0 plus b into minus 12 equal to minus 1. Therefore, b is equal to 1 by 12. Now, we substitute both values in this. Therefore, s plus 3 upon s square minus 4s minus 32 is equal to 11 upon 12 divided by s minus 8 plus 1 by 12 upon s plus 4. Now, applying L inverse on both sides, we get L inverse of s plus 3 upon s square minus 4s minus 32 equal to L inverse of 11 by 12 upon s minus 8 plus 1 by 12 upon s plus 4. Now, by linearity property, 11 upon 12, L inverse of 1 upon s minus 8 plus 1 by 12, L inverse of 1 upon s plus 4. Now, using the same formula that we have used in previous example, L inverse of 1 upon s minus 8 will be e raised to 8t, and L inverse of s plus 4 will be e raised to minus 4t. So using the same formula, we get 11 by 12 e raised to 8t plus 1 upon 12 e raised to minus 4t. Again the denominator is same. Therefore 11 e raised to 8t plus e raised to minus 4t divided by 12. This is the Laplace transform of the second example. Inverse Laplace transform of the second example. Let's study one more example of the same type. Example number 3, 1 upon s square plus 2s. Again, if you observe, the degree of numerator is 0, degree of denominator is 2. So degree of numerator less than degree of denominator, as well as the denominator can be factorized as s into s plus 2. Therefore, we can apply the same case for the example. So 1 upon s square plus 2s can be written as 1 upon s into s plus 2. Again, if we look at the denominator, the factors are real and linear. Therefore, we will express it as a upon s plus b upon s plus 2. Cross multiplying and cancelling the denominator, we get a into s plus 2 plus bs equal to 1. Now we put s equal to 0. Therefore, a into 2 plus b into 0 equal to 1. Therefore, a equal to 1 upon 2. Similarly, if we put s equal to minus 2, we get a into 0 plus b into minus 2 equal to 1. Therefore, b is equal to minus 1 by 2. Now, substitute both values in above. We get 1 upon s square plus 2s is equal to 1 upon 2 divided by s plus minus 1 upon 2 divided by s plus 2. Apply L inverse on both sides. Therefore, L inverse of 1 upon s square plus 2s is equal to L inverse of 1 by 2 upon s plus minus 1 by 2 upon s plus 2. Now, let's use linearity property to separate. So, 1 by 2 L inverse of 1 upon s minus 1 by 2 L inverse of 1 upon s plus 2. Now, using the formula of inverse Laplace transform, L inverse of 1 upon s is 1. L inverse of 1 upon s plus 2 is e raised to minus 2t. Therefore, we get 1 by 2 into 1 minus 1 by 2 into e raised to minus 2t. Denominator is same. Therefore, final answer is 1 minus e raised to minus 2t upon 2. Now, in this video, we have studied 3 different examples of the same type. That type number 1, the roots, the factors are real and non-repeated. Linear factors and non-repeated. So the same case we have studied for the 3 examples. In the next video, we will study how to find the inverse Laplace transform when the factors are repeated.